Hello and welcome to Polynomials Part 1. Polynomials are mathematical expressions which play a crucial role in algebra, in calculus, and much beyond. But here we'll be restricting ourselves to Class 10 syllabus of CBSE. Now let's try to understand how we can define a polynomial or what algebraic expressions can be put under the category of polynomials. Now if I take an expression say 2x squared plus 3x plus 1, here I notice that the variables are x square, x, and here it can be taken as x to the power of 0. All these variables have a positive integral index. So whenever an expression has all variables raised to a positive integral index, then it is classified as a polynomial. If any one of these variables also does not satisfy this condition, it ceases to be a polynomial. If even one of these characteristics is missing in any one of these variables, then also it ceases to be a polynomial. For example, if I write 2 root x plus 1, now this does not is not a polynomial because this is 2x to the power of half plus 1. So half is not an integer. So this is not a polynomial. If it is 2x to the 2 by x plus 1, so this becomes 2x to the power of minus 1 plus 1. It becomes negative. So this is also not a polynomial. So if any one of these criteria are missing, it's either negative or it is a non-integer, then also it ceases to be a polynomial. So in order to identify a polynomial, we must check all the variables of all the terms and see whether they are positive and integral in nature. Now this is a general representation of a polynomial. This is a nth degree polynomial because the highest index of x is n over here. So this is called an nth degree polynomial. Here a1, a2, a3, these are all constants, and xn minus 1, these are all variables. Now a polynomial can start from degree 1. So this is a degree 1 polynomial called a linear polynomial. Then we have, these are quadratic polynomials, and you can have cubic, you can have biquadratic, you can have any degree of the polynomial. Even if the degree is 0, for example, in the case of say I write only the constant, here the degree can be taken as 0 because x raised to the power of 0 does not have any impact, it is equal to 1. So this becomes 2 into 1, that is 2. But a 0 polynomial or a 0 is called the 0 polynomial, and the degree of a 0 polynomial cannot be defined because even if you take 0 into x to the power of 0, that makes it 0 into 1, that is 0. So 0 polynomial, in this case, the degree is not defined. And for constants, we call them constant polynomials and the degree is 0. Now, what do we understand by a 0 of a polynomial? So this particular concept, we are going to first study algebraically, and then in the later on videos, we'll learn about it graphically also. Now, what do we mean by the 0 of a polynomial? Now, in any polynomial, whatever degree it has, if you find constants which allow the polynomial to reduce completely to 0, then that particular constant is called a 0. And the number of zeros in a polynomial will be defined by the degree of the polynomial. So in order to find the 0 of a polynomial, the polynomial equation fx is equal to 0 must be solved and the factors must be found out. So let's take an example. Supposing I have this polynomial fx is equal to x minus 2 or a function in x. So this becomes, if fx has to become equal to 0, then x minus 2 must be equal to 0. So x is equal to 2. So 2 is the 0 of this polynomial. 2 will reduce the complete polynomial to 0. Now if fx is 5x plus 4, that means if fx has to reduce to 0, then 5x plus 4 must be equal to 0. So x is equal to minus 4 upon 5. So this is another 0 of this polynomial. Now if I take a quadratic polynomial, this is a second degree polynomial. So at most it will have 2 zeros. They can be dissimilar or they can be similar zeros. So here, first let us find out the factors of this. So x squared minus 4x plus 2x minus 8. So or fx becomes equal to x into x minus 4 plus 2 into x minus 4, or fx is equal to x minus 4 into x plus 2. Now, if fx has to become equal to 0, then x minus 4 into x plus 2 must be equal to 0. So, the zeros are 4 and minus 2, two unlike zeros. Now, supposing I take a quadratic polynomial x squared minus 2x plus 1. Supposing this is a polynomial fx, x squared minus 2x plus 1. So, here this becomes equal to fx is equal to x minus 1 the whole square. So, fx is equal to x minus 1 into x minus 1. So, if fx has to be equal to 0, then x minus 1 into x minus 1 must be 0. So, x is equal to 1, 1. Two similar zeros with the same signs. So, this is also possible. So, in a quadratic polynomial, we can have at most two zeros, and if both the zeros are same, they can both be positive, they can both be negative, or one can be positive, one can be negative. So, at the most, this quadratic polynomial will have two zeros. Sometimes it does not have a zero, and those cases later on we'll refer to, because in those cases you do not get an exact value of the zero. So that has to be dealt later on. Here we are confining ourselves to real values and where we get exact zeros over here. So that is it. Now let's move on to relationship between the zeros and coefficients of a linear polynomial. Now in a linear polynomial, the highest degree is 1. So if we have to find the zeros of a linear polynomial, if I have to reduce this polynomial to 0, what do I do? If fx has to be 0, then ax plus b is equal to 0. So x is equal to minus b upon a. That means the 0 is referred to as the negative of the constant by the coefficient of x. In the case of a linear polynomial, negative of the constant term divided by the coefficient of x. Coefficient of x. But in the case of a quadratic polynomial, what happens in the case of a quadratic polynomial? Let's take an example. First of all, a quadratic polynomial is referred to as ax squared plus bx plus c, and it has two zeros, alpha and beta. Now, alpha plus beta is equal to minus b by a, and alpha beta is equal to c by a. So before we take an example, let's try to understand how we get this relationship. So ax squared plus bx plus c is the polynomial, and if alpha is 1, 0, x minus alpha can be one factor. Beta is 1, 0, then x minus beta is another factor. So the polynomial ax squared plus bx plus c can be written as k into x minus alpha into x minus beta. Here k is the constant, and we take the help of the constant over here to equate these two expressions, because we do not know the value of either this expression or these zeros over here. So in order to equate them, we need to take the help of a constant k. So this becomes equal to k x squared minus alpha plus beta into x plus alpha beta. So this can be written as kx squared minus kx into alpha plus beta plus k into alpha beta. Now, because these two expressions are same, we can equate the coefficient. So a is equal to k, b is equal to minus k into alpha plus beta, and c is equal to k into alpha beta. Now, if I put the values of a is equal to k over here, I'll get minus b upon a is equal to alpha plus beta. And if I put the value of a over here, I'll get c upon a is equal to alpha beta. That means the sum of the zeros is the negative of the coefficient of x by the coefficient of x squared, and product of the zeros is the constant divided by the coefficient of x squared. Now here there is an example where we need to find the zeros and verify the relation between the zeros and its coefficients. Now supposing we have to verify the relationship between the zeros, first we need to find the zeros. So fx is equal to x squared plus 4x plus 3x plus 12. So I can write this fx as equal to this, or fx is equal to x into x plus 4 plus 3 into x plus 4, or fx is equal to x plus 4 into x plus 3, or fx, if fx has to be 0, then x plus 4 into x plus 3 must be equal to 0. So x has to be equal to minus 4 and minus 3. Now alpha is equal to minus 4 and beta is equal to minus 3. So alpha plus beta is equal to minus 4 plus minus 3, that is minus 7. Alpha into beta is equal to minus 4 into minus 3, that is plus 12. And minus b upon a. Now b over here is 7, a is 1, c is 12. So minus b will become minus 7, a is 1. So this becomes minus 7. C upon a is c is 12. So 12 upon 1, that is 12. So you see alpha plus beta is minus 7 and minus b upon a is minus 7. Alpha beta is 12 and c upon a is 12. So this is how we verify the relationship between the zeros and the coefficients. Let's take another example. Fx is equal to 6x squared minus 3. So we need to find the zeros of this quadratic. Here a is 6, b is 0 and c is equal to minus 3. So let's find the zeros. So I am taking the help of a square minus b square formula. So we can write it this way, minus root 3 whole square. So this, or fx, will become equal to root 6x minus root 3 into root 6x plus root 3. So if fx has to be 0, then root 6x minus root 3 into root 6x plus root 3 must be equal to 0. So x has to be equal to, from here we get 1 by root 2 and from here we get minus 1 by root 2. So alpha is equal to 1 by root 2 and beta is equal to minus 1 by root 2. So alpha plus beta is equal to 1 by root 2 plus minus 1 by root 2, that is 0. And alpha beta is equal to 1 by root 2 into minus 1 by root 2, that is minus half. So sum of the zeros is 0 and product of the zeros is minus half. Now minus b upon a. B is 0. So this becomes minus 0 upon 6, that is 0. And c upon a, that is minus 3 upon 6, that is minus half. So here also the relation has been justified. So relationship between the zeros and the coefficients has been justified in this case also. Now with that we come to the end of this presentation. Hope you liked the explanation. So kindly like and subscribe to my channel, and I'll continue with more sub concepts in the next video. Thank you for watching.